Welcome back, everybody. Don't forget to hit the subscribe button. I think I'm up to like 87 subscribers now. Is that what it is? 87? Let's go. We're getting famous.
Yeah.
I wonder how many. I wonder if anybody's view. No, I have to keep making them. I keep making them unlisted. I got to make them public.
Yeah.
Yes.
Yeah.
So the world can see.
Because say someone needs help on their math, they'll look it up.
I know they could be like, hey, I want to subscribe to Mr. Albert.
Technically, you can still find the unlisted videos. You just simply have to search for them directly.
I thought it was like if you had the link.
Now, you can still find them.
Oh, you can? Oh, I mean, I don't really care.
Yes.
Whatever. So, taking a look here at section 2.4, day 2. The rules that we've been working with are still applying, right? We're still using inverse operations to solve these things, right? Inverse operations to solve. Remember what we talked about yesterday when we said get rid of the little guy, right? Get rid of the little guy, right? Okay. Taking that into account, try to solve the problem on the left side there. Just go for it. You should be able to do it. What's going to happen?
What do we do if there's no little guy?
Right. What do we do if there's no little guy? Well, move one of them. Move one of them. Just you pick. Oh. People are kind of like, oh, what is happening here? We got this. And then the little guy, there is no little guy, right? So we would subtract 2x. Oops, sorry. Subtract 2x. We get, well, the variables cancel out, right? Oh, that's weird. So we end up getting this statement, right? So what is my answer? Is my answer 6? Is it 0? Is it 1? Well, let's think about this. Okay, Hayden is very confidently saying 0. Hold on, hold please. He is very confidently saying 0. How would we check his answer? Plug it in for x. So let's try it. Let's see. Let's see if Hayden is right. 2 times 3 plus 0 is equal to 2 times 0. Oops, did my parentheses the wrong way. 2 times 0 plus 6. So he gets 2 times 3 plus 0 is 3. 0 plus 6. Is Hayden right? He is right when he says 0 is an answer. Sure. Yes. Anything could possibly be a solution here. Anything. Anything you want. 4. Yes. 1. Yes. A million. Yes.
So if we get that on the test, we can just write a bunch of random numbers and be right.
No.
Oh, okay.
I want all real numbers. If people get lazy and they start writing this symbol, that's fine too. That's the symbol for all real numbers. I've seen people, did you ever have a teacher that writes this, ARN? Somebody way long ago started doing that. And I don't remember, that's kind of like phased out. That must have been an old teacher. But all real numbers, or the real number symbol, that's a bold R. That is a 2 lines. And then you start on the first R and then down to the second R. And it's just like a bold type R. But what is that saying? That's saying that in this case, this would be any number would work for this situation. That any number would work. That is what's called an identity. Okay? You see this on your guided notes directly to the right. It's what's called an identity. It's called an identity. When the variables cancel out and you get something true, it has an infinite amount of solutions, meaning any number that you possibly can think of, if you plug that in, the left side will equal the right side. It's an equation that's always true. Okay, so what would happen if you solve the next one on the left side? Keep going down the left side. Your left side. What would happen if you solve that one? The variables cancel out again, right?
Yeah.
I don't want-
You subtract 2x from both sides, you get 3 is equal to negative 4. So what do you think is the solution here? Right.
2 divided by 3.
No, I'm done solving.
So that's the solution.
Is it 3? Is it negative 4? Is it 0?
Undefined.
Hey, Hayden, you were right the last time.
There is no solution.
Nothing?
Cannot be solved.
Nothing at all.
No.
Yeah.
We've got an infinite amount. There's no way. There's got to be something I can plug into that.
No.
Too bad. He's correct. Nothing that you plug in will work. You could try forever and ever for the rest of your life. If you tried to find an x value that would make this equation true, you'd be out of luck. Plug in 1, plug in 0, plug in negative a million, whatever you wanted to. Nothing would make that equation work. So the answer is, this is a symbol for no solution. No solution. That's the symbol for no solution. It's not a 0. Be careful. That's not a 0. That's no solution. What this is formally called, and you can see it on your guided notes there, it's formally called a contradiction. A contradiction. You know what that word means? That's not just a math word. When you state a contradiction, you're saying something that defies something that you've already said. Right? You are saying these two things are equivalent. Solve this equation. Oh wait, nothing will work. Okay? With solving an equation, if you get a false equation in the end, the reason we knew it was a contradiction was because we got 3 equals negative 4, which last time I checked, 3 was not equal to negative 4, right? You get a false statement. When it's a false statement, it's no solution. All right, start doing the next one down below. Go for it. I wonder what this one is. It's probably going to be either an identity or contradiction. Okay, the 10 and the 1 will make an 11. Again, same rules. Don't start moving things across an equal sign before you simplify. 7x and negative 12x make negative 5x plus 11. Now we move the variable, but look, oh, they're the same. Once they're the same, alarm bells should be going off. Something weird is going to happen. Okay. What is this? What's my solution here? All real numbers. All real numbers. That is not an IR. That is just an R. It's a bold type R.
K with like a weird, like an R.
Here, how about this? Is that better?
Yeah, now it looks more like an R.
Oh, yeah, look for in the box.
Try the next one. It looks like we get 13x on both sides. Okay, my variables are equaling out. That means they're going to cancel. Is that a true statement?
No.
What's my answer?
There is no solution.
No solution. Again, if you wanted to write out the words, no solution, that would be fine. Don't put like, not gonna do it, or like, don't put nothing, or don't put, just write, no solution. Okay, we've done one of each. Gotta figure out that one. Okay, it looks like my variable's gonna cancel out again. I've got 3 y's. There they go. Okay. What's my answer? No solutions, right? Not all real numbers, no solutions. No solutions. Our variable's completely canceled out. We get a false statement in the end. No solution. Questions about that? All right. So let's take a look at some word problems now. Okay. That was a little deviation away, a little sidestep away from solving or getting one solution. Now let's go back and say, okay, what are the other types of word problems that I could use here? All right, 4 times Greg's age decreased by 3 is equal to 3 times Greg's age increased by 7. How old is Greg? Let's go ask Greg. All right, so let's take the words and turn it into math. Take the words, turn it into math. 4 times Greg's age decreased by 3. Let's just take this chunk. What would that be?
Like 4a minus 3 equals 3.
Oh, he's going at 4a minus 3, right? 4 times Greg's age, I'm assuming a is his age, right? 4 times Greg's age decreased by 3. Now, is equal to, okay, that's easy. And then we've got 3 times Greg's age increased by 7. Like, what did you say for that one?
3h plus 7.
3h?
Or 3a, sorry.
3a plus 7. Good. So if you take it piece by piece, it's not that bad. Okay, let's solve and see how old Greg is. We subtract 3a from both sides. That's going to give me a minus 3 is equal to 7. A is 10. Greg is 10. Make a statement. Greg is 10. We feel okay about that? Try the next one down there. A painting company charges 250 base plus 16 per hour. Another painting company charges $210 base plus 18 per hour. How long would be a job that they're going to cost the same amount? Now, man, I do problems like these all the time. Like I want to spend the least amount of money I can on my house and doing jobs and things like that. People will come out and give you a quote and say like, okay, this is how much I'm going to do this job for. They'll give you an hourly rate. They're not sure how long it's going to take. They'll give you a base price and then an hourly rate. Usually it's like a base price amount to come out and then an additional amount per hour, like electricians and plumbers, and they all work on the same type of thing. It's a price to come out and then an hourly price that you'll have to pay them for however long the work takes. So if you've got a couple different quotes, you want to figure out, okay, which one's going to be the best deal. If I think this job is going to take like 5 hours or so, you set up an equation for it. Okay, so this one place A charges $250 plus an additional $16 per hour. That's the expression that represents the total cost for the first place. The second place charges $210 base. Probably like the paint and the setup and everything, plus $18 per hour. But they charge a little bit more per hour. So notice how this place is a little bit less of a starting value, but they charge more per hour. This place is more of a starting value, but they charge less per hour. I want to know how long would be a job when they would be equal. So let's solve this equation here. The little guy is 16. So we subtract 16h from both sides. We get 250 is equal to 210 minus 2h. And then we subtract the 210. We get 40 is equal to negative, wait, positive. I was going to say, there's no way that should be negative. And then we divide by 2, so 20. Okay, if the job is going to take 20 hours, if they're painting a whole house or something, the job is going to take 20 total hours, that's when these companies will be the same. Okay, 20 hours. Does that make sense?
Mhm.
So now we know everything there is to learn about solving equations. Okay, we've got variables on both sides. We've got what happens in special cases. Everything there is to know about solving equations. All right. So long, everybody watching along at home. I'll see you guys later.